In this video, we are going to see the features of angles in parallel lines. So there are three different kinds of angles you will find in parallel lines. One is called corresponding angles. Corresponding angles. Okay, let's write the full words. We have the short form called CORR angles. Next, we have alternate angles, ALTERNATE angles, so which is called ALT angles, and lastly called interior angles, so which is called INT angles. Next, let's see how we can identify the angles. So let's start with the corresponding angles. I will be marking it in yellow. So in each of the figure, you will see there are two parallel lines. Both of them, they're called AB, CD. There should be a line cutting across the parallel lines. The line is called transversal. When the line is cut across the parallel lines, you can see it makes the two angles on the top right-hand corner. These two angles in the figure called A and B, they are called corresponding angles. So it's like the two angles, they are located in the same position. For example, top right-hand corner. Similarly, we can find a number of or other pairs of corresponding angles in the figure, like C and also D on the top left-hand corner. For example, like E and F, so they are at the bottom right-hand corner. In parallel lines, corresponding angles are equal to each other. So A is equal to B, or C equal to D, or E equal to F. So these are called corresponding angles. Next, come the second one. I'm going to use green color. We have the same parallel lines called AB, CD, and a line called transversal cutting across the parallel lines. But this time we will be focusing on the line segment of the transversal between the parallel lines. You will see it makes like a Z shape, or you may like an N shape, or even like this shape, and then in which there are two angles between it, so like C and D here. And according to the feature of parallel lines, the angles, alternate angles, are equal to each other. So as for example, next time if you have a parallel lines going like to the northeast direction, on transversal here, then this C and this D will be equal to each other. Or you can say this E and this F, they're equal to each other. These are called alternate angles. Finally, I'm going to use red to talk about interior angles. This time, we are not talking about the angles are equal to each other, but the sum of these two angles are equal to 180. Once again, we have two parallel lines, AB and CD, and we only look at the line segment between the parallel lines. And now there are two angles, E and F, in the shape of like a C shape, E and F, or maybe you can say it's like a U shape, E and F. These two angles will be supplement to each other, which makes a 180 when you check for the sum. This is called interior angles. Now let's have an intuitive idea to see why corresponding angles are equal to each other on parallel lines. For example, in this figure, we have angle A and angle B, which are corresponding angles. You can see that the angle A is made up of parts of the transversal and parts of the line AB. If you try to slide towards AB, it eventually goes to the position at angle B. And this is why we have A, the value of A is equal to value of B. You can use the same idea to prove the other pair of corresponding angles are equal to each other. For example, now I mark C here and D here, the corresponding angles on the parallel lines. And you will see angle C is made up of parts of the parallel line AB and also parts of the transversal. If you try to slide or translate it towards or downward to line CD, so it moves here at the position D. So it explains very briefly why C and D are equal to each other. Next, we come to the case of alternate angles. We also have line AB, CD, which are parallel, and we have a transversal over there. The mean of alternate angles means that when you have a like Z shape along AB, transversal, and CD, so it makes two angles which are called A and B, and they are alternate angles. Now we are going to explain why the alternate angles are equal to each other by an intuitive idea. We use the same way. Angle A is made up of parts of the line AB and parts of the transversal. So now you can see like a 7 shape or V shape over there. When you slide along or downward, it moves to the position here. So as a result, you will see that A and this angle, which are marked in should be in blue, should be equal to each other. Moreover, can you see that there is a big cross over there, which means we can apply vertically opposite angles to explain why the blue angle, which is equal to A, equal to B afterward. So as a result, you can see alternate angles are equal to each other in this very simple moving the angle A downward. Finally, we come to the case of interior angles. We also first draw the line ABCD first with a transversal. Interior angles comes from like you have a U shape, like the green U or green C over there, and inside this C shape or U shape, you have two angles. I also label them as angle A and B. By using the same method then we can move the angle A to a new position, at which I mark it as red as follow. This red angle and the blue angle together made up the adjacent angles on straight line. That means it's equal to 180. Finally, it explains to you why angle A, angle B, interior angles in the parallel lines add up to be 180. So let's see whether these intuitive ideas of understanding corresponding angles, alternate angles, and interior angles help you. So let's continue to see some examples to apply the three reasons or three features we learned about in parallel lines. So now can you see that in this question, the 60x and x will be hide in a U shape or C shape. So in this situation, it refers to which kind of angles we're talking about. Yes, that's very good. It's interior angles. So as a result, in this question, the answer will be quite easy, having 68x degree plus x equal to 180. Because of interior angles, and then we say the lines AB and CD, they are parallel to each other. By using calculator, or you can do it mentally, so finally it is 112 degree. Next, we come to, this is called number 4. So it seems like a very hard question, but if you look at the features or the positions of the angles, you will see that like PQ and RT and PT can be considered as the transversal. So afterward, now can you see that 100 degree and this 31 and x together, so they are called, yes, alternate angles, because the shape is like this now. So this is called alternate angles. So instead of trying to draw different lines or finding different values, so the question can be simply like x and 31 degree here or together, so which is equal to 100 degree by the reason called alternate angles. This time it's not AB, but we call PQ parallel to RT. So as a result, x finally would be 69 degree. So that's about number 4. And finally, now we come to number 6. So this is a question that students may confuse about, because at first some students may think of, well, is it like alternate angles? No, sorry, because alternate angles should be talking about like PBC and also BCS. The two red angles are called alternate angles, but now it's not the case in this question. So that's why we failed to apply this method, but we use another. So the correct solution, we turn to green color. Now in this question, in our observation, can you see that 76 and x are too spread in the figure? That means they are too far away. So in geometry, one very intuitive idea would be you try to gather or you try to move the information as close as possible so that they can relate to each other. So as a result, the angle x, I would prefer to move it towards the position at point B as well. Can you figure out the reason? So it is two parallel lines, x is on the right, we shift it to the left. This is, yes, very good. So this is corresponding angles. So that's why we have QBC equal to x, which is called corresponding angles. We can take a longer line, PQ parallel to RS. If you like, you use BQXS, I think it should be okay. So afterward, so this is the first step. It's not yet finished, but we successfully try to put the x and 76 as close to each other. So the last job will be, now you can see the green angle and 76 make up or appears in the big cross. So this is called vertically opposite angles. And finally, you can just say the green angle, which is x, equal to 76 degrees because of vertically opposite angles. And it completes the question. At last, we try to see a harder question to end the video talking about parallel lines. Now you can see the question AB and CD, they are parallel, but luckily we don't have a line to join them together. So some students may think of adding AD, but it may not be a good choice because you cut x into two pieces. And so that's why it's not a very good way. And now I try to rub it away. Okay, rub it away. And afterward, normally the way how we do would be, we try to add a line which is parallel to AB and CD. So that's why in the question, we are going to add a line cutting across E. Maybe I just call it F. So that's why I will draw EF such that means so that. So you want to give it a condition such that AB, so it's already parallel to CD, now it's also parallel to EF. And at the same time, we'll put an arrow on it. The benefit on it will be, now can you see that originally the green lines, they are not connected because AED, it is a broken line. But now, after adding this EF, you will see a very big benefit, which is you can see ABEF, it makes up a U shape. That means it's about interior angles. Okay, so I write down interior angles here. Whereas the other side, I mark it in yellow, EF and CD, so there's a EZ shape, or in other words, it's about alternate angles. So as a result, now we can mark it. So the yellow angle appear at E, which is called 36, whereas this one can be used difference of 100 and the answer in order to find it. And now we work out the answer one by one. First of all, we have FED equal to 36 degrees, which is called alternate angles EF parallel to CD. Second line, we focus on the red angle, which is called angle AEF. It's 100 degrees minus 36 degrees. And the reason is called, sorry, no reason, because it's just simple calculation. So that's why it's 64 degrees. Finally, we come to the X, our ultimate goal. X and the latest 64 degrees made up by 180 because of interior angles AB parallel to EF. So it completes the question having X to be 116 degrees finally. And here's the end of the video.